I think we have this spectrum of capability we're trying to develop for a long period of time. At the end of this road, we see a disaster response robot, like a firefighting robot, for example. And Fukushima collapsed and happened that we can't really send anybody. We would like to send a robot instead. Same thing for the building fire. Once you have a building fire, we'd like to eventually send a human, instead of human, we'd like to send our robot to see if there's any victim, see if there are any more dangerous event coming, so we be able to respond in the beginning. And if you step back, there's a lot of things we can do. And then at this point, the shorter term goal is inspection robot in hazardous environment. For example, building in power plant, in chemical plant. There are many areas where environments are not very friendly for human, but you want to do some simple tasks like measuring some temperatures or some chemical components, and you might be able to close or open valves, some very simple manipulation. Simple inspection from distance you can do with flying drones, but it's very challenging to go through door, for example, and then close up inspection inside the building. I think legged machine will be the best fit for that kind of test. So eventually we're trying to build a machine that can go anywhere human can go. Because as I said before, the wheeled vehicles are the dominant platform we've been developing so far. And then there are so many places we can go with that kind of system. And stairs are actually one of the most popular obstacle for us, because if you imagine a machine that can moving around in our man-made environment, the stairs is one of the biggest challenge. And a lot of tracked vehicles designed to climb upstairs, the efficiency and their reliability is still suffering. So we still think the legged machine will be the best suited for even man-made environment. And of course in disaster there is going to be a lot of obstacles. The Cheetah, the robotic Cheetah, the MIT Cheetah project was started with the very pure passion. I would love to design a machine that can run like an animal, like run really fast. So we've been focusing on high-speed locomotion and then like agile jumping and so on. And so Cheetah 2 is not quite designed to perform specific tasks we want to do instead of human. So when we designed Cheetah 3, we start putting a lot of practical requirement on the design space. So we slow down the speed, because when you inspect or when you do tackle some situation, you probably don't need like a 16 mile per hour speed. So we actually slow down. Instead of we increase the payload, so we should be able to carry heavier sensors, heavier cameras, and so on. And we should be able to exert high forces on the environment, to open doors. Typical doors in the facility in the power plants, those are really heavy. So we increase the torque, and we also increase the range of motion. So the Cheetah 3 have a 12-degree freedom, 12 electric motors that can articulate the body and the limbs. Yet the range of motion you can reach is still not as good as animals, because animals have about 600 muscles. But we cannot put like that many electric motors, so we have to minimize the number of degree of freedom. But yet we want to keep the larger workspace. The one way to do that is to maximize each joint, the workspace. So we eventually achieve reasonable amount of reachability of the entire machine. So the Cheetah 3 is a lot more all-around player. It can do decently high-speed motion, but at the same time it can be very quiet, very precise, and at the same time it can be very powerful. So it is a lot more close to the actual machine that can move around freely inside of buildings and then perform opening doors and closing valve, kind of very simple task. So we have to design our gripper specially suited for opening many type of doors. And we believe that the hand design doesn't need to be as complex as human hand. We believe that it's going to be much simpler. And we can also have a customized swappable hand equipped on the machine. So if you know the building, if you know the door type, we were going to just equip those grippers on the machine. And after walking toward the door, and then the robot will just pick up from the body. And then now I will equip this hand, and then you can open the door with this limb. We try to utilize the best aspect of quadruped. Which is the best for mobility, but we can articulate you need to have another hand, so we try to stand up or stand on the 3 legs, and then use the fourth limb, and then equip with the customized swappable hand to open the doors and closing valve.